we will continue our discussion on the principle of hydraulic machines and system design. So, we are discussing about the pumping system design. So, today we will discuss on another aspect that is probably we have discussed that from any existing pump house, if we need relatively higher amount, maybe that amount is not been possible to supply by the existing pumps. So, what we need to do for that case, that is what we will discuss today. So, this schematic tells us that in a pumping system, whenever pumps are connected other pumps are installed in a house, pump house, depending upon the requirement, that is very much process specific, we connect pumps either in parallel or series. Normally what we need to do, it is seen that from the normal practice, normally whenever a designer design the pumping system, it is always advisable to okay, we will have a few pumps, although the net demand or net requirement will be met by a particular pump, but will be met by a particular pump, but by a given pump, but it is always advisable to keep at least another standby pump only to have a flexibility in operation. On the other hand, if the pumps are run by electric motor, in that case we have to have another pump that will be operated by IC engine, rather diesel engine, only to have again safety for the entire system, because if electricity supplied is stops, then probably entire water supply will be interrupted, and for that, to mitigate that demand during that crisis period, we need to have one pump that will be run by diesel engine. So, with that, today we will continue. Let us say that the requirement of the system, because of some new equipments or maybe a new process plant, requirement of the system is becoming double or maybe higher than the present system requirement. So, the industry people always will try to get that amount of water from the existing pump house, because as I said many a times that installation of pumps in a new pump house, or rather construction of a new pump house, will have two different costs. One is of course associated with the construction of the house itself, and second one is because again we need to employ another operator to operate the pump in the new house, and for that again we will have a running cost. So, it is not suggestive or rather advisable to have a new pump house. Of course, if the space and other requirement is there in the existing pump house, then only you can go for that, otherwise of course you have to go for new pump house. So, if the demand is increasing, let us say by double or maybe higher than that, then maybe demand is such that by running two pumps again in parallel, we are unable to meet the demand. So, what we have to do, again we have to install a new pump. Now, as I said you that the new requirement, but the additional requirement may coming from new process plant or a new equipment. So, whenever we are supplying that additional amount, so whenever we are supplying or rather we are transporting that additional amount to a new process plant or to new equipments, of course system resistance will differ. So, in that case what we do, so to continue that, again we will draw a schematic and we will explain briefly that how we can design that system. So, suppose we have a sump. So, in that case we have one sump, this is reservoir or sump, from where maybe two pumps are connected. These two pumps are connected and they are supplying water to a common header. So, this is known as common header. And as I said you that to increase the safety of the system, again we have to have another pump that will be operated by diesel engine. So, maybe we are having another pump of same capacity, but that pump will be operated by one diesel engine. So, that is only for to bring the safety of the system. Now, as I said you that maybe situation demand is now increased to supply additional amount in different another or newly installed process plant or newly installed equipment, such that even by running this existing two pumps, let us say the pump is P1, P2 and this is P3. So, if one pump P1, P2 and P3 are identical, all the pumps are identical, because they are maybe each of them are delivering meter cube per second, that is discharge against a head of H, So, all these pumps are identicals, maybe all the pumps are radial flow pump. Now, as I said you that even by running two pumps at a time, that is 2 cube is not sufficient to meet the demand because of the newly installed plant or newly installed equipments. So, what you have to do, again you have to install another pump. My question is, suppose if I draw the H cube curve, so since all the pumps are connected to the common header and from there maybe another line is connected to different parts of the different places, they are supplying water at different places. So, if I now what are our objective is, so we need to operate two pumps in parallel, so that the discharge by both the pumps will be just double. So, suppose H cube curve for a given pump is like this. So, if I for any pump P1, P2 and P3 is separate pump altogether, because that is operated by diesel engine only to bring out the safety of the system. Now, if P1 and P2 both the pumps are connected in parallel only to have higher discharge maybe, and then what will be the head discharge characteristics, because both are identical, maybe we will get. So, this is two pumps running in parallel, and this is single pump. So, now question is, if the system resistance curve is like this, then of course this will be our operating point. So, the head or discharge corresponding to this point, head and discharge corresponding to this point P. So, this is QP and this is HP. So, head and discharge corresponding to these points are the rated discharge and rated head that we are going to get from the system. Now, maybe this amount is not sufficient to supply to meet the demand. So, what we have to do, again we have to install another pump. Should we go for the same pump, or maybe depending upon the requirement we have to install another pump. Now, question is, as I said long back, that whenever installing another pump, it is not possible that we will get the same pump from the pump manufacturer. So, anyway we have to have another radial flow pump, and the pump will be of same speed, and if we install another new pump with the in parallel with the existing pumps, and both the pumps are now connected in parallel. Now, suppose this is newly installed pump and this is now connected to the common header. So, this is P4. So, P4 is the newly installed pump. This is newly installed pump. So, this pump P4 is a newly installed pump, and that is connected with the existing pump house. So, what you have to do? So, maybe by running two P1, P2, P3 are we are calling this, let us say group 1 pump. So, these are I am calling group 1 pumps, and P4 is another pump, that is group 2 pump. So, by running two pumps in parallel of group 1 pump is not able to meet the demand. So, what we have done, we have installed another pump, group 2 pump, and that is being connected in parallel with the existing pump, and it is connected to the common header. Now, so if I install new pump, and if the, let us say the demand is such that the P4 pump is supplying, let us say head is near about, shut off head is near about or nearly equal to the existing pumps, or but we need maybe a little bit amount of water we need to get from the existing pump. So, if the H cube curve of the new pump is like this, say sort of head is nearly equal. So, like this, then if we add this one, so this is for group 2 pump, this one for group 1 pump, two group 1 pumps are running in parallel. In that case, again our system resistance will be if we run all the pumps in parallel, then again the total H cube curve, that is whenever 2 group 1 pumps and 1 group 2 pumps are connected in parallel, then H cube curve will be like this. So, this is the curve, when 2 group 1 pumps and 1 group 2 pump, group 2 pump are in parallel. So, now our new design point will be same. If now we will discuss a few aspects. So, whenever the new pump is installed, maybe from the common header, now we are connecting 2 different branch line. One is going to the newly installed plant, and another is supplying to the existing points. So, although all pumps are running in parallel, but the entire system will follow the least system resistance out of these two different resistance, because one is going to the newly installed plant, one route, another route through which we are supplying water to the existing points. Now, I do not know the system resistance in which is more. So, that is what is big problem. Now, so if this is the system resistance and if this is the least system resistance, then of course the operating point now will be shifting to another point, that is let us say R. So, now this will be the QP, QR, and the head will be almost HR. Now, if I trace back from this operating point to the individual pump, then maybe this is the discharge supplied by the group 2 pumps and this is the discharge supplied by the group 1 pumps, individual group 1 pumps. So, this is the point and the head and discharge corresponding to points is the discharge and head supplied by each of the group 1 pumps, and this is the point corresponding, head and discharge corresponding to the points are the head and discharge that will be supplied by group 2 pumps, rather newly installed pump. My question is fine, because in that case we assume that the system it will, so all the pumps running connected in parallel, they will run if and only if all of them are experiencing the same system resistance. So, this is very important, we need to know. So, whenever you are connecting pumps in parallel and they will run, each of them will run if all of them are experiencing the same system resistance in which they are connected. So, now as I said, if I trace back from this newly operating point to the individual pump H cube curve and the points where they are intersecting, now the head and discharge corresponding to this point, let us say this is R1 and this is R2. So, the head and discharge corresponding to R1, that is the head and discharge that will be supplied by the newly installed pump. It might so happens that the discharge corresponding to point is so high that the power requirement that depends highly equal to rho Q G into H. So, discharge is so high, maybe head is manageable, that head that is supplied by the pump is fine, but the discharge is so high that the power, that is input power requirement from the electric motor become high and pump trips. So, if this is the power, that is the power requirement, rather QR1, I will write in a more accurate manner. So, rho QR1 G into HR1, that is the power required to drive the new pumps. So, this is the power required to drive the new pumps. So, what we have to do? So, if this amount, so I do not know if QR is so high that maybe okay fine, whenever pump manufacturer is supplying pump, it is clearly written that pump should be able to deliver from 25% to 125% of the discharge from its base design point anyway. So, if the QR1 and HR1 and these are very, HR1 is okay fine, that the head is fine, but if QRN is very high, maybe we are not expecting that amount of Q from the pump 2. So, if this power requirement is very high and that power is not able, that power will come from electric motor, and if that power is goes beyond the electric power supplied by the electric motor, then pump will trip, and that is very an undesirable phenomena. So, of course, we have installed, maybe we have installed one pump, that newly added pump only to get the additional requirement, but because of this undesirable phenomenon, we are not able to supply the additional requirement and pump should trips, and it has been seen many a times by the industrial engineer that they are seeing this kind of problem. So, that means because why you are getting, because as I said you, we do not know the, because water is now from common header, what is now conveyed, water is conveyed to different route, to different branch lines. So, I do not know which one is the least resistance of the system, but it is quite common, and it is obvious that whenever pumps are connected in parallel, they will run if and only if all of them are experiencing the same system resistance. So, and it is also true that they will always try to follow the minimum system resistance. So, I do not know if the existing system resistance become minimum. So, this will happen, and for that pump 2 may trips if the power requirement goes beyond to the supplied power by the electric motor. In that case, what you have to do? So, this is a very big problem. So, now I will briefly discuss in a very in short that how we can get readout from this problem, rather how we can get how we can eliminate this kind of problem. So, what I will do now? So, as I said you that we can have a very simple analogy, that what I said, that maybe we are supplying Q amount, and that Q amount is now maybe divided into Q1 and Q2, and we are getting additional total Q amount. So, Q1 should go to the newly installed plant or newly installed equipment, and Q2 will go to the existing system. But since all the pumps are running running in parallel, so all of them will be experiencing same head, let us say delta H, otherwise they should not run. So, if this is the case, so then what I can do? So, delta H experienced by the existing pump house, let us say, because now we are having two different system, one is the existing system, let us say that will be what? That, so total dynamic head will be equal to H static plus K into Q square or Q1 square. Similarly, the same head will be experienced, so H static of the existing system, Q1 of the existing system, and that head will be same head that will be experienced by the another pump when that is supplying water to the new system plus let us say K1, and this is K2 Q2 square. So, this is new system. So, this is the condition based on which these two pumps will run. Now, my question is, where K1 and K2 are loss coefficient of flow, loss coefficient for flow. So, maybe Q1 is going to the new system and Q2 is going to the old system. So, I know what is the amount of Q1 and Q2. I can calculate this total static height because I know the elevation level between the pump house and the new system and the existing system. So, I can calculate H static in both the cases. Only thing I need to know what should be the K1 and K2. So, question is, when I will calculate K1 and K2, and this Q1 plus Q2 should be equal to cube. So, I can now solve by knowing K1 and K2 that what is the amount of Q1 and Q2 that is going through different path. By how I can calculate K2, because delta H, that is very important, that is a head that will be the head developed by the pump. So, if I know that delta H is equal to H static plus K1 Q1 square, where Q1 I know if I know the delta is, that will be developed by the pump, and H static I know, from there I can calculate K1. Similarly, I can calculate K2, so by knowing K1 and K2, and in that case if I solve this one, that H static for existing system plus K1 Q1 squared, that will be equal to H static for new system plus K2, where Q2 square is equal to Q minus Q1 square, because I know that Q2 is equal to Q minus Q1, where I know total Q, where Q1. So, solving this I can calculate, because I know the total Q requirement for both the plants. Now I have calculated K1 and K2, I know the static height for both the system, now I can calculate Q1. So, from this analysis we can calculate what is the amount of water being supplied by the pump to the new system. So, and once I know the Q1, then I can easily calculate Q2. From there we will have a fair estimate about whether all the plants, other new plants and existing plants are getting proper amount or not. If that is not the case, then what we have to do, we have to redesign the system. That means if Q1 is less, then we have to know that the new system is having higher resistance, and because of what, entire system is following the least system resistance, that is the system resistance of the existing system. And since it is following the existing system resistance, and if I trace back that point to the new pump house and new pump HQ curve, and discharge corresponding to the point may become so high that the power input, the power required to operate the pump is high, rather that goes beyond the electrical motor power and pump trips. So, in that case, knowing Q1 and Q2, I can calculate that, okay, fine, whether both the plants are getting desired amount or not. If they are not getting, then again we have to redesign the system. By how? By altering the system resistance. How we can alter the system resistance? In an existing pump house or in existing systems, we can alter system resistance, because this K1 Q1 square and K2 Q2 square, static height we cannot have any alteration. It is very difficult, because once they are installed we cannot change. Only we can change, that is the K1 loss coefficient of flow, by changing the valves or fittings, etc. Again, what we can do, see, in an installed plant valve we need to have valve only to have a flow control. Again, pipeline frictional resistance we cannot change, because once pipes are installed or once pipes are laid down, how we can alter the pipe diameter and all those things, again it requires huge cost. So, what we can do, another one aspect is to provide some orifice plate only to kill the resistance or to increase the resistance. So, either we can from the existing system we can increase resistance to bring out the resistance equal to this new system, or what we can do, we can reduce the resistance of the new system and to bring out this equal resistance to the new existing system. So, but the good suggestion is that we have to reduce or we have to bring down the system resistance of the new system, as well as we have to increase the system resistance of the existing system, so that we can bring up at a particular level, so that both the pumps, all the pumps will run system smoothly without having any trouble, as well as both the system will get the equal amount of discharge. And this is what an important design aspect of the pumping system. As I said that I can eliminate or I can reduce the system by eliminating one valve if it is not required, or some fittings by redesigning, or sometimes if I need to increase the system resistance, then if the existing system we need to increase the system resistance, how we can increase? Only by providing orifice plate. So, if I provide orifice plate, it can be designed that orifice plate if I provide, that will kill some amount of head, and some amount of head being developed, and it will increase the system resistance. So, this is all about the design aspect of a pumping system. If we would like to add new pumps with the existing pumps, and the new pumps will run in parallel, and sometimes it happens that the newly installed pump or newly added pump trips, immediately it starts to run. So, we need to investigate from where the problem is coming, and then we need to sort out the problem by suitably calculating the system resistance and system design. Fine, with this I stop here, and I will continue with the next topic. Thank you.